Ready? Also, just in case if you wanted to, I can see that this unit 35 is going to be in milliliters. I'm going to get this and I'm going to write this out over here. 35 milliliters times 2, what's my SI unit? Grams per milliliters. Isn't this over 1? So in this case, this is at the bottom, this is at the top. They cancel out, and that's the reason why grams is my SI unit. Okay, I just wanted to show you the algebra of it. Or my shortcut way, which you might have already been taught this. I'm looking for mass, so I'll cover up mass. Mass equals D times V. D times V. Density is 35. Volume is 2 equals 70 grams. Okay, so that's how I do my shortcut math or my math for algebra. And I also teach physics class as well. And I teach my physics students to do that as well. Whatever shortcuts you can do to get through with things quicker, I really like that. I don't want you to have to be suffering through math. Alrighty, so let's look at the next part. The next part here is some problems for you to do. I'm going to have you practice or start on these when we see each other again, which is going to be, I think Tuesday, right? When we see each other again for our teams meeting, I will then go through this, and we need to go ahead and be prepared. So that means whether you did it or not, when I call your name out on the teams meeting, make sure you're ready to go ahead and answer the questions. Okay, so those are going to be vocabulary words that you found on the first couple of pages that we've talked about. This is going to be a density problem that we've already practiced. We've got matching up here, matching over here. Over here, they're going to talk about volume and size and density. And then on this side, they're talking about density again, and there's a couple math problems. Okay, so what we've already done, we're going to pause for a moment and we're going to practice, because we need to practice what we've done before we continue to go forward, if that makes sense. We're not done yet with our notes, right? Let's go ahead and do a little bit more notes, and then we can pause, take a break, and then we'll have video too. Okay, so let's go ahead and keep going. Now that we've talked about properties, we talked about physical properties, we talked about chemical properties. Now we're going to talk about what we call changes, okay, with matter. So now we're going to talk about physical change, and just like we did before, we're going to talk about chemical changes. So there's physical and chemical. There's physical and chemical properties, there's physical and chemical changes, okay? So let's go ahead and get through that part. We're going to pause then the video, and then we'll take a break, come back, and then will be video number 2 for the notes. Alrighty? So let's do this part. Physical changes does not involve a change in the identity of the substance. It still is what it is. So one more time. Physical change does not involve the change in the identity of the substance. Let me give you a couple of examples. What about when I melt ice? Okay, yeah, it was a solid, and yeah, it's a liquid, but the identity of the substance, isn't it still the same? H2O solid and H2O liquid. What if I get an ice cube and I smash it? Okay, so I had a big giant ice cube, I smashed it, now I have a whole bunch of little pieces. Isn't it still H2O? Still water. What if I cut it? What if I had, like those big people, like those people with those big old, like huge giant things of ice, and they get the chainsaw, like they make all these nice little sculptures. What if they just got a big giant ice cube and they cut it in half? Isn't it still H2O on both sides? Still H2O. Let's go ahead and give another example. Dissolve. Let's go to a different example here. Dissolve. If I've got sugar and I dissolve it into my Kool-Aid, if I had a sugar cube or a big thing of sugar and I dissolved it, it's still going to be sugar. It's just so tiny that you can't see it with your eyes anymore because it's dissolved. Okay, it is so, so tiny. Your eyes cannot see it. What about crystallization? Crystallization. Had to stop for a moment. Crystallization. When you crystallize it, right, those atoms and molecules now are just going to form that solid again. They're just going to come together and just be nice, tight, and compact. The same atoms, they just smushed and they're frozen together. They crystallized. Okay? So, first thing is our states, or what we call phase changes. Okay, and I know you talked about phase changes already, like in middle school, right? Solid, liquid, and gas. And we use that S, L, and G when we're talking about compounds, okay? So please know those, S, L, and G. Now, a solid is going to be something that's going to be tightly packed. It's going to have a definite shape and volume, and the atoms or molecules vibrate in place. There we go. Let me scoot this over. There you go. So they're tightly compact. They have a definite shape, right? Like an ice cube is going to be a definite ice cube shape. And the volume's going to be the way it is. Now, ice cube's kind of like not a good example. What about your kitchen table? Think of the tabletop of it. It's got a definite shape. It's got a definite volume. I mean, could you smush it and make it tighter? I mean, no, those atoms are pretty much compact tightly already, right? Now, the atoms and molecules, they're actually moving and they're vibrating in place. And they can't really move around, and they don't have any space to move around. Not like a liquid or a gas. They're smushed together in place. Ready? Let's look and talk about the next word. The next word is liquid. It takes the shape of its container. It has an indefinite shape and a definite defined volume. Like the volume is what it is. Okay? Go ahead. So imagine you've got some water or you've got some Gatorade in a container, right? And even if you have it in a cup, could I compact and shove more Kool-Aid or Gatorade or water in there? No, it has a definite volume. The amount it has is the amount it has. It can't really have any more, right? The word definite volume means that it cannot compress. You cannot compress it really anymore. It's like as smushed as it could. Now, truthfully, could you? Yeah, but you know what? Personally, I don't think I'm strong enough to do that. You're going to have to get some kind of machine with who can handle the pressure. We can't do that. We can't compress it anymore. It's compressed as it can get. And then the last one is gas, gaseous. They fills the entire container. Right? Unlike the liquid, where it takes the shape of the container, but the top part of it still is there, open space. It's in. It has an indefinite shape and volume, meaning that you can think about a balloon, and I don't mean like a balloon with helium. I'm talking about just like a balloon that you blow up. Can't you get that balloon, the end of it, and smush it, and you change the shape of it? And if you smush that balloon really tight on this side, didn't you change the volume size now? The balloon was bigger, but now you smushed it together and you made it smaller, right? It is compressible. Okay? It is compressible. I am going to pause there the video. Okay, let me put that notes there. I will go ahead and download this part. We'll have part 1. We're definitely going to have part 2. I'm not sure we're going to do part 3 or not, if we have to do that as well. We've got some more stuff on the next side, and then we've got some practice problems. We're going to talk about energy and the conservation of energy law, which you already know. And then in our notes, we're going to classify and actually break matter apart into the substances that it is. Okay? Then on the last page of your notes, we're going to talk about separation techniques. Remember how we talked about over here? How, was it here? Oh, sorry. It was on the video, and we were talking about the pure substances, that it couldn't be separated anymore, not by physical means, only by chemical. And if you chemically separate it, it's no longer what it originally was. Okay, so we'll talk about the difference between mixtures versus pure substances as well. Alrighty, so pause for just a moment. Then we're going to turn around, start off over here at this side. Don't forget, when we see each other on the Teams meeting, be prepared to ready to answer those questions. Let's make sure that we're all on the same page here, practicing. Okay, and I will be back. Bye-bye.